My name is Landon Hawley. I'm a consulting architect. Work with Ansible and our West Consulting Group. And I'm here to introduce Logan Best, and he's going to talk about some of the network automation that he's been doing.
Thank you. Awesome. Well, I hope everybody's food coma after those tacos is all right. So, luckily, I'm standing up, so don't fall asleep. I'm here to talk about what it's like, and we're still in progress, but what it's like greenfielding network and systems automation in the New York City subway and other rail networks. So I will hop right into it. Obligatory Ansible slide. I've been programming for about 21 years now. I've worked in the data center industry for about 8 years at this point. Actually, 8 years this week. I started out with systems engineering, eventually graduated to network engineering, and now I'm officially DevOps, whatever that means. I've been using Ansible for about 5 years now. I fell into it as part of bootstrapping servers at my previous job, which was a public cloud. That eventually led into infrastructure as a service, private cloud build-outs, disaster recovery automation, and backups automation. Then I decided to move into BGP peering configs because I got tired of typing that out every day. And then I got tired of doing route policies manually, so I automated that. And now I moved over to customer provisioning, which was really just migrating Perl scripts to Ansible. So that was a headache and a half. What's my favorite thing to do when I Ansible? Well, yeah, obviously. So just as a disclaimer, this talk is intentionally vague, in some cases due to NDA and IP proprietariness. So understand that. Also, any opinions expressed are of my own and not of my employer. Also obligatory. So how many of you have been to New York City? How many of you have known that there is Wi-Fi and cellular networks in the stations? How many of you have used it? Awesome. That's a lot of people. Any feedback? Because I could bring that to my managers. None? Cool, I guess it's good. I'm going to assume that. I'll tell them that. So we have 472 stations that are covered in New York City. 409 of those are underground with cellular, Wi-Fi, and emergency services. The rest are above ground with just emergency services for the time being. Wi-Fi is planned on those. Timeline not necessarily thought out yet. This is some of the equipment that you may see in the platforms. On the left there, you have the square box that has a UPS in it. It also has the fiber access panel and a Alcatel-Lucent switch. That long skinny box, that's what does all the cellular. All the head ends are in our data centers. We have 5 data centers around New York City. All the carriers will give us the RF. We convert that to optical, send it over our dark fiber, and we convert it back to RF right here in the stations. These are our AP boxes with a little fiber access point right there. One antenna is dedicated to cellular, one of them is Wi-Fi, and one of them is emergency services. When I say emergency services, rail operators can use radios to go over the emergency services band. There's also little help points that you'll see in the stations. Those also go over this antenna. This is what our core network looks like, and it's purposely obfuscated. So if you see a lot of 0/30s, trust me, they're not the same one. So we have 5 data centers, like I said. You can kind of see the groupings of the blue NXOS boxes. Those are our core routers. We have ASRs. We have a whole slew of things in our core network that aren't even listed here. So yesterday, Brad had a talk, and he was asking about, how many vendors do you have to support? And he stopped at 6, and I still had my hand raised. How many has more than 6 that they have to cover in automation? 1, 2, 3, handful. Okay. We have a lot. And the problem with this is we have to meet certain standards in rail environments because they're dusty, they're hot, really hot, and they could also get really cold. So a lot of these devices that are in the stations have to be mil-spec, they have to be hardened, they have to be passively cooled, which also means sometimes lack of features. So that gets really interesting really quickly. How many here has spotted red flags so far? Only one person with red flags? Cool. Well, so where's the systems in all this? Yeah, we got Debian, we got Ubuntu, CentOS, Proxmox, Oxidize, Zabbix, and the list goes on and on and on. There's probably 30 plus 40 more things that we have to integrate into our automation to make things work properly. So what does this all come down to? We have a massive footprint of vendors, versions, and platforms to cover. Almost all of our devices are in New York City, and that's almost 20,000 so far and growing, especially as we branch out of the city, which is coming. And if that wasn't enough, network CLI just isn't enough sometimes because, again, lack of features. Some of these things don't support SSH. Yeah, so no netconf, no HTTP API. We have to write expect scripts and execute that with Ansible. So that's really fun. And those of you who hasn't raised their hand for red flags, you might want to reconsider evaluating that. Oh yeah, there we go. And this also means there's loads of underlying groundwork required in order to get automation in such a large and vast network like this. So how do you even begin automating a massive network, largely using unsupported Telnet and Ansible with expect scripts? Ideally, you talk to your peers, look at the existing pain points, see what you can automate, get the small, easy wins. Use those wins as leverage. What's the low-hanging fruit? For us, the low-hanging fruit was actually systems automation because it's really easy to do that. So bootstrapping servers, getting everything on a consistent deployment, replacing systems that are out there with new templates, doing Proxmox and Netbox integrations. The Ansible Proxmox modules aren't super great. They're getting better, but they're not super great. So we have to do native Python and Proxmoxer API. Syncing all the 6 clusters of Proxmox servers that we have, getting all those VMs accounted for in inventory in Netbox was pretty difficult. But it's done. And that was a really big win for us. Because now we know what we have and where. We tie it into our IPAM now, which is also Netbox. And it gives us a lot of flexibility with using that as dynamic inventory. We also have SIMC. We use UCS everywhere. So tying in SIMC into our automation helps. We could deploy LDAP really easily within the network through automation now. One of the big things that was needed is actually DNS infrastructure. A lot of everything, still a lot of things are relying on IPs. And 20,000 devices, that's a lot of IPs to remember. So everything's in Excel sheets. And nobody likes that. Yeah. So another low-hanging fruit was just deploying nice DNS infrastructure, automating updates to that as things get pulled into automation, as things get pulled into Netbox, tie those into the DNS automation, get them online, get them registered with FQDNs and proper setups. The next thing was also DHCP. We get DHCP requests all the time, sometimes in bulk of 30 stations at once. And that's a lot of groundwork in order to do. It takes me with an Excel sheet with an assload of macros to build these DHCP configs and then manually paste them into the DHCP, do the sync for the HA, and yada, yada, yada. It takes about 3 hours to do 30 stations. Now, we just type in those stations. Well, we started out typing in those stations into Ansible params, extra vars and such. That would go out, provision the DHCP, get it done nice and easy in a few minutes. We've graduated since to using Jira tickets with custom fields. That way you put in the subnet, you put in the VLAN, you put in everything that's needed in the custom fields. It will ship it out automatically into our automation and deploy it within minutes. So now, that also means there's change control built in. It was also a really big win and a fairly easy win to get set up. Another low-hanging fruit is just reporting, figuring out what is out there, gathering facts on the live network and the production network, and not relying on Excel sheets, as accurate or inaccurate as they may be. Mostly inaccurate. So, we look at current projects. Find out what your team and your related teams are working on. How can you help with those projects? Are there big enough projects that there's enough repeated tasks that you can get those small wins again? And how can those tasks be automated? You know, talk to your teammates. You may not know what they're working on or have experience with the devices that they're working on, whether or not you have access to them. So, what was missing in our infrastructure that we needed that required all this groundwork to be laid down? Turns out it was a lot. Source of truth is one of them. That ended up being NetBox for what we chose. Previous experience with NetBox at my previous employer made it really easy and really cheap and not SolarWinds. I got the question from management, why not use Zabbix? We have one of the largest Zabbix installs in the world that Zabbix knows about, with a 13 terabyte database currently. That's a lot to maintain. But it also means, ideally, that every one of our devices is in there. It's not, as we found out. So, Zabbix or any monitoring tool should never be used as a source of truth, despite what anybody says. Don't do it, and holy hell, not Excel sheets. I'm going to keep drilling that into you guys. I know somebody here is using Excel sheets. I don't want to see hands, but I know somebody is. The other thing was secrets management. How do we remain compliant with ISO 27001 and also handle password management and secrets management, SSH keys, and all that? We decided to deploy HashiCorp Vault. It works out really well. There's really good integration with Ansible. Everything is easy peasy. Next thing, CMDB, obviously. That's a mixture of NetBox and Jira. And also central authentication. At the time of my hiring about 10 months ago, everything, and I mean everything, was local auth. 20,000 devices with local auth. That's not easy at all. I feel sorry for the guys that had to add my user to those. Another thing is self-service. As I was talking to my teammates and cross-functional teams in the org, I realized that there were a lot of people that don't have CLI experience. Field techs just want an easy way to hop on their phone and do something. Oftentimes they don't have a laptop. They'll have testing gear. They'll have RF gear. They'll have everything but what they need in order to hop on a CLI and do these things. So we have to build some sort of self-service portal for NetOps and NOC teams to be able to do these automation changes without having to bug me every single day. And one thing that I learned, I sort of knew it going in, that I was going to be the only one with programming experience in the company, but I was willing to accept that on the condition that long term I could hire more. Still a work in progress. So developers. We need more, and we will. soon. So that's a lot, right? So how do we even get started? Well, luckily, one of my teammates had already started dabbling with Ansible. He actually mentioned it in my interview, and I was really excited to hear that. He was also really excited to know that I had Ansible experience, because that means he has help. Luckily, we have the crawl, walk, run principle that has been mentioned many times throughout this conference so far. Keep it simple, stupid, please. Go for the small things, go for the simple things, make it easy, and then grow from there. And I put network audit in here. It's a little vague, but luckily we had a full top-to-bottom network audit going whenever I was hired. So it was fairly easy for me to just kind of latch onto that project and start pulling reports in support of the audit. Stuff like, how many interfaces do we have in this data center that are used and unused? Are they actually used? Are there VLANs on them that shouldn't be there? If somebody plugs in a cable, are they going to get unauthorized access to something, potentially a customer, that they should not have access to? So getting all that information for the audit was pretty crucial, and they were doing that manually. I changed that real quick. Another thing, maybe like what VLANs are present in every station switches, or furthermore, what interfaces had VLANs on them and were they admin up or down. The audit was completed over a month ahead of expectations. They were actually expecting to be delayed over a month. So with just these small wins, just doing reporting, not making any changes, just literally getting facts from the network is all it took to start winning over management. And I have a big emphasis on team training and buy-in. Some of this I've already covered buy-in, but team training is massive when it comes to automation and introducing new things to a large organization that has never had something like this before. It turns out that when you come in saying you need 4 people to start doing training and certifications and go to conferences with a $20,000, $30,000 budget, you're going to get eyes raised and people are going to start walking away from you. I didn't realize that. So, yeah, I'm not management. I'm an engineer. So I had to go for a different approach. I had to start doing some training myself, which is okay. I actually like it, and it allows me to learn more about what I'm teaching, which is also why I do talks like this. Yeah, and I mentioned earlier, like, use the small initial wins as leverage for all of this stuff. So let's break it down into the crawl, walk, run principle. My number one goal in our automation journey is team education, because I cannot do it alone. As much as everyone may think they could do it all alone, you really can't. You need help in some capacity from somebody in some way. So educating the team, educating your peers, cross-functional teams on what automation is, how it's helpful, why they should use it, why they should be excited about it is really big. Lay the groundwork to either build a robust monitoring solution or enhance the one you have. For us, we had the largest known Zabbix database, so it was pretty robust for us already. However, it still needed some work, and there's still work happening with that. In fact, our monitoring is so important to our automation strategy that I tied it into our education training. So much so that myself and 3 other teammates spent all last week in Zabbix training. 2 of us, myself included, were there for the certifications as well and took and passed as Zabbix certified professional, so yay. So yeah, luckily our monitoring was already good enough for us to get some automation going and start introducing input validation. Because in reality, like, aside from the efficiency, we really want input validation. We want to reduce human error, right? So putting that input validation to reduce the change risk was crucial to getting started. And that's as simple as verifying whether or not a VLAN ID is an integer, or verifying that what you're about to do is really what you want to do. Maybe you mistyped something and you put a VLAN number in the VLAN name on accident. You need to check for stuff like that. So then we kind of move to walk. We introduced NetBox as a source of truth. It's a very daunting thing to import 20,000 devices into NetBox and get it structured in a way that is meaningful. In fact, that is not even close to being done. But it's a work in progress. IPAM was a big, easy step to move forward with that one. DNS was also a big thing, so we put all these devices in our NetBox, but they're not really structured, they're just there. And that's sanitizing, importing all these Excel sheets, physically verifying information in some cases in our data centers, physically mapping our rack elevations, which didn't previously exist, and tagging. Tag everything. It doesn't matter, tag it. If anybody's not familiar with NetBox, it's like groupings in a way, but it's tagging. Someone in Network to Code Slack actually mentioned the tagging strategy called namespace tagging. I don't remember who it was. Maybe Tyler remembers. I don't remember. Which I immediately loved the idea, and that's as simple as just putting like some kind of prefix, a colon, and then what the actual tag is. It gives it some sort of namespace meaning. It adds a lot more flexibility to it, and you could do multi-dimensional namespacing as well. Using the facts from the network to populate config contexts in NetBox was a big win for us. Setting up internal DNS infrastructure to get away from IPs everywhere and simplify our Ansible inventory. Introducing free IPA as our new central auth. Migrating all local users to LDAP. And Radius users, setting up service accounts for automation and other items that need access, such as Oxidized, and not using somebody's personal account for everything. And then also starting small with making changes to the network. When I say small, I mean something simple like just really small Jinja 2 templates and just shipping those out. Little small additive configuration changes is all you really need to start making a huge difference in the network. For us, that was deploying DNS changes and deploying AAA changes to get the authentication and everything ready for Radius. We started even further than that and started just with our core IP network, and specifically at one of the smallest data centers that we have, serving only about 50 stations, 45 stations. So it was a lesser footprint to hit. It was a little easier to mess up if we needed to. Didn't, luckily. And lab everything. Lab. We have a large, very large, I think 2 or 3 GNS3 hosts, big hosts, that our engineering team uses religiously to model changes that they made manually. So that was already a huge win, knowing that that existed and knowing that our engineering team relied on it very heavily. So we can model all these changes knowing, with GNS3's limitations where necessary, how these changes were going to affect the network. So tying that into our automation was pretty crucial in order to test these changes as well. And you better be testing changes. Please test your changes. Don't just ship the prod. And run. NetBox implementation complete. We're not there yet. This is a long road for something like this. So I'm looking at maybe possibly mid next year we'll have NetBox implementation complete. Our monitoring adds new automation and device-specific metrics. So we realized that the monitoring wasn't covering everything. There were still things that it needed to cover, things that are related to automation, things that are not related to automation that automation could affect and start tripping on our monitoring that wasn't being caught before. So we have to add these things before we start doing massive automation changes and verify that these monitoring metrics are working and the triggers are working and the alerting is working. Implement rollback options. Somebody's going to mess up at some point. I have. I will again, I'm sure. So this means that we have to integrate with our Oxidized backups, which is our backup solution of choice for network gear. and make a backup before the play runs. That's implemented in every single playbook that we run. Every single playbook that we run is required to have backup role at the very top, because that's going to get hit first. We want to make sure that we have consistent backups every time something is run. And yes, that slows down the process, but it's better, in my opinion. We also wanted to drastically reduce field tech provisioning by implementing zero-touch provisioning in conjunction with Ansible. There's a really good blog post on that. If anybody's interested, I could pull that up later. I think it was specific to Ansible as well, which was cool. And all they have to do is make sure the interface, the management interface, has DHCP configured on it. They plug it into a provisioning network. Zero-touch provisioning kicks in. Our MAC address database will find it. Ansible will take that from there, figure out what the golden config is based on the MAC address and what tagging it has on it in Netbox. And it will ship the configuration right to it, log into the switches above, upstream of it, reset the port, reboot the switch, or AP or whatever it may be, into its new VLAN, production VLAN, and now everything is good. That reduced field tech time from 3 hours-ish down to about 2 minutes. All they have to do now, because all of our stuff comes DHCP enabled, is just plug it in and then get their stuff ready for their tests. And while they're getting stuff ready for their tests, the thing's already provisioned. It's ready to go before they are. So if your org doesn't already have good change management and project management culture, in my opinion, this is a must. We prefer Jira for everything. ServiceNow is a great product as well. There's all kinds of different things that are out there. Whatever you're already using is most likely good enough. But be available and be mindful that there may need to be additional options for some of these items. You should have seen the, the drools from management's faces when I told them I was going to implement auto-documenting change management too. That was a huge win. Basically what that means is you could open up a Jira ticket. It will automatically start shipping everything. And I mentioned this earlier about the DHCP pools. All that stuff is auto-documented. So once it hits Ansible, Ansible is going to reach out to the device or the DHCP server, both, figure out what the existing current state is. It's going to make a comment on the Jira case with that existing state and the full config for that specific section that it's entailed. And then it's going to make the changes, and it's going to post that new config to Jira as well. So now we have the before and the after, all within the case that is related to the topic. If you have a CAB, a change board, you could tie in change control with Jira as well. So if 3 people need to approve a change, the Ansible playbook will hit the devices, get the current state, post it to the Jira config, and just sit there and wait for the change approval to come in. That way the managers just go to Jira, they look at what changes are wanting to be made, they immediately see what the existing config is, and then they could approve it or disapprove it. And then once the approval goes in, Ansible will automatically go through and make the rest of the changes, post the updates to Jira, and close the ticket as long as everything is successful. Network to Code has a really great talk that Jason Edelman did in New York City, I think earlier this year, on this very topic with ServiceNow. And it is recorded and it's on YouTube. I would highly recommend checking it out. It goes really into depth as to how all this stuff works. And in fact, I even used that as a basis for how to get this working with Jira. So highly recommend it. It's really cool stuff. And you will win every manager over in your company for a long, long life. And of course, continue iterating your automation so that less and less manual changes are made to your devices. So how are we doing all this? This is our stack. Some places we're using native Python to do the automation. Ansible, AWX, Netbox, StackStorm, Zabbix, Jira, Slack, and Viewflow.io. Some of you may be wondering why I haven't mentioned StackStorm at all yet. Basically, StackStorm is a workflow management platform. There is a free version. There's also a paid licensed version as well. And it's a really, really central part of our automation pipeline. So most of the workflow traverses through StackStorm in some capacity to route specific actions to different tools all at the same time. In some cases, StackStorm is even listening for changes and acting on those. So in the case of the DHCP pools that I keep mentioning, we fill out this JIRA case. StackStorm is actually listening for that particular project for a new case to open up. Once a new case opens up, StackStorm pulls all the custom fields in. It will sanitize everything, and it'll send the message to our Slack. Actually, there. So JIRA takes it. StackStorm will receive it. StackStorm updates our GitLab with the inventory information in Netbox. And Slack, it'll also post a message to Slack saying, hey, this automation is running. This is what's intended to be done. We're moving forward. StackStorm then hits AWX. AWX will start running Ansible playbooks. Those Ansible playbooks will start communicating with Slack as well along the way, so that we get live updates as to what's happening. Pulls the dynamic inventory from Netbox, hits Kea, which is our DHCP server, and what I didn't put in here actually is hits our Nexus devices and updates the SVIs for the DHCP pools that are needed. All of this is happening all at the same time, and we're getting live updates in Slack and in JIRA at the same time. So where's the highly dynamic part? Well, Wi-Fi on board the trains. We're not there yet, but we will be. And this is where it gets really vague, so I'm sorry, but we'll go through with it anyway, and I could possibly take some questions afterwards privately, not on recording, and we'll see what I can say. So here's a sample diagram of 4 train cars. We typically have 8 or 10 cars in the New York City subway. I'm just using a small subsection of that. There's different classes of cars. There's an A car, there's a C car. I don't know what happened to B. They never answered that question. I just forgot it existed. So, and this is not specifically NYC subway related. Every rail vendor has classifications of cars that have certain equipment in them, and some other classifications have different equipment in them. Like such as the front and the back will have certain items that are certain pieces of equipment that are not in the middle cars. Sometimes there's A cars. We'll treat A cars as the head and the caboose. C cars are in the middle in this case. Sometimes there's an A car in between C cars. We don't exactly know what all these different configurations are going to be at any given time on any different rail vendor or rail operator. So we have to consider all of this whenever we're putting Wi-Fi and everything on the trains. We have to assume the cars won't stay together. And we know there are some rail vendors that will disassemble every single car, every single train stretch, every single night. And there's no guarantee that any particular car is going to meet with the same car the next day. NYC Subway does it a little bit different. They split it in half, and they have half segments that are together. But we don't want to rely on one specific rail vendor's options for disassembling their trains in the yard every night. So we have to keep it dynamic. This is where it gets really difficult and vague. So A cars will always be at the front and the back of the train, sometimes spread out throughout the middle as well. C cars are everything in between. So how in the world do you keep everything consistent in the network whenever you never know who your neighbor is going to be the next day? It gets really difficult, and I can't say exactly how, unfortunately, because that is proprietary, and I designed the solution for that, and it's really cool. I will say that it's all using every protocol that you already know. It's using existing routing protocols, and it's very fast, and it's tested, and it's really cool. But this is where ZTP comes into play a lot. So whenever a car boots up, all the devices are going to boot up at the same time. And we have a function in place that wipes the config and forces ZTP to initiate every single time it boots up. This gives us the flexibility to be able to change where a car is going to be or where a router is going to be and auto-detect its neighbors once it loads. So it's going to get the golden config. That golden config is already set up to figure out what its neighbors are going to be and automatically provision itself once the golden config is in place. So that's where it gets really, really sticky, because I see some heads nodding. There's a lot of things that could go wrong with that, and we find them, still find them. But this is where ZTP is actually used even more heavily in onboard train networks than it is in the station level network. Even though it's not even in production yet, we're still using ZTP more heavily in the yard right now, doing testing runs than we're doing out in the field in the stations. Essentially, what could happen is the train will go in the yard at the end of its daily shift. The train gets dismantled, serviced in a variety of ways, again, depending on the train operators involved. And we just have to be mindful of that, and it gets really, really difficult. So how do we keep our sanity? Rigorous testing, which is what we're doing now. Very, very rigorous testing. Sometimes that means overnight sitting in a train yard, working with train engineers, as weird as they are, and and making routing changes and making ZTP changes and getting good at everything, so much so that I can now write a white paper on it. And I might have to, unfortunately. Innovate using existing protocols as much as possible. There's a lot you could do with existing routing protocols that many people aren't really aware of. Some of that comes down to CCIE level knowledge of things. Hopefully you don't have to get down that deep, but be wary that in a highly dynamic network like this, you have to get down that deep and know exactly what the control traffic of these routing protocols are doing to a deep, deep level in order to optimize everything to be fast switching, fast provisioning, and also solid. It has to be solid. Eventually, train operations are going to rely on this network as well. So we have to be bulletproof when it comes to that point. For now, it's just going to be revenue service only. And have a backup strategy for when everything blows up, because it's going to blow up eventually. For whatever reason, it may be an earthquake, it may be somebody diddle-daddling with an AP in the ceiling illegally. It may be anything. Something's going to break at some point. Have a backup strategy, figure out what that's going to be, and set up your redundancies properly. In the end, don't be afraid to start slow. I've been telling this to everybody all week. Start slow, start small, and don't be afraid to do so. You have to use those small, little incremental steps to start winning over people. Have a well thought out vision for what you want to do in your automation strategy. Because if you don't, you're just going to be changing focus all the time. You're going to be pivoting regularly, and you're never going to get anything done. So have a big vision, try to phase it out in different ways. Figure out what you need to do, and again, start small. And back to the original slide, keep it simple, stupid. And advocate for education for yourself and your peers. That will go a really, really long way. And as everybody knows, you will eventually break something. You will. That's all I have. Thank you.